Happy Friday once again, guys. Give you guys a little inside background scoop. I've done some videos that I just kind of embarrassed to release. You know, I thought they were kind of dumb, but I take a chance and release it anyway. And sure enough, somehow, some way, somebody gets something out of it. It could be something in the background, it could be something I said, or how I'm doing something, but I'll get a comment that somebody will say, "Thank you for the video." So, not too many videos ago, I did a video on making a dovetail cutter, indexable dovetail. And that video was completely inspired by Randy Richards' channel. He showed a dovetail cutter and got my curiosity, is this really better than an off-the-shelf cutter? So I was very reluctant to shoot and release that video because Randy's making them and selling them, and here I'm showing everybody how I'm going to make one, or made one. But the kick is, shortly after the video released, there's a comment left, "Thank you very much." A gentleman made one. And a little bit after that, another comment's left by the same guy, Scott, saying he made another one. And then the next thing I know, he shot and uploaded a video showing it off and personally thanking me for showing him how to make one of those. So Randy, I hope I didn't step on your toes, but and I encourage everybody. Dan's hobbies, he's only got a few up there, but I'm subscribed to him. His work and how he's doing things is incredible. So I encourage everybody, even if you do 1 or 2 videos, do something, post it. You have no idea how it may impact somebody, somewhere, somehow. Alright, so for the final on the Boll Areo engine, the diesel engine here, this is the final, so I hope you guys enjoy it, and I'll see you next Friday. Alright, I think you saw this setup that I did before. For rounding out stuff, I'm making the piston rod here. And I did one side, you just put the gauge pin back in there and then clamp it down and you're doing the other side. This little vise is priceless. I've used it so many times. Forgot whether I went in or not here. No. Well, just a matter of moving the axis and spinning it around. I can zoom in a little. There it is, done. Yep, there's the guy. This is crazy. Whoops, wrong way. So that's the part. Spinning around a little bit so you can see it. So I'm not sure how I'm going to do that other than standing it on end, which means I'm going to have end mill marks in it, but it came out pretty good, Making the cylinder part. My favorite TCMT 2151 Cobra carbide inserts. So taking 5,000 cuts. Almost like a mirror here. 5,000, go. Auto key. Take 100 thousandths off of it, and I'm just using, like I said, regular motor oil, nothing fancy. Oh, Just wanted to show it. Okay, progress so far. Carburetor's just about there. This should have screwed all the way down, but more Hansen threading die, rethreading die problems, and that'll go all the way down. This doesn't, so I'm probably going to wind up shortening it, but I've got no way of holding it to do it. Needle fits in there perfectly, you know, Loctited or something. Yeah, it's a little bit of play. I think temperature is playing around here, but so that's kind of done. This part was not too easy. I haven't done the boring inside yet because I need the material to do all the final stuff now. But the only way to hold this was on the new lathe, which still has some issues, and chatter was a problem. I was supposed to go in a lot further, but I wound up just kind of milking it to get it to happen. Went in 90 to 100 thousandths on it, so you don't see the screws, which they show in the picture you're supposed to see. And I haven't done this to final height yet, so it's extra tall. Drilled the holes out on it. Made this guy, just now finished it, 1144, because you can get an easy, nice finish on it. Comes out great. 1/8 inch hole. So I'm very close, but I need to get the cast iron and some other stuff here to be able to do the piston. Well, the piston's supposed to be cast iron. I'm not about to start this until I've got to do the inner piece, and then the piston goes in it, and bore this, and then I can do I guess the crankshaft's the last piece. But I'll make a call. I had everything in the cart at Speedy Metals, and kind of a kick because all of it came to $14 but $20 shipping. I called them and they just, oh, that's what UPS charges. Right. So I had it in the cart, and I finally added more stuff to make the shipping worth it, and hit purchase, and it took me right back to the credit card page. So I don't know if I placed the order or not. I have to go to Marshall's, I guess, and get the right 4 screws for this and restock everything that I've used here. So I'm getting very close. I don't think there's anything I can do now until I get cast iron and other stuff here. Alright, just starting to turn the shaft for the engine. This will be the outside where the prop goes. And this is the new insert, Sandovic, that did a killer job on Dan's machine. So he sent me one and I've been playing with it, but I still haven't gotten completely into SFM and RPM, but I do have the power feed engaged. No, I don't. Let's get it engaged now. But when you think about it, I did run a test indicator on this before, and I think it's about 4 thousandths per revolution. But the RPM and the feed rate are tied together. So if you go faster, it feeds faster. If you go slow, it feeds slower. It's still, I think, the same feed rate. So just to prove it, alright, so I'll just do a slow RPM. You come in, do a 3 thousandths cut, right? There's 3. And it's kind of an okay finish. Do it one more time just to make sure. Yeah, it's not even cutting. Going. Because this guy is supposed to cut the other direction. So I can't really do the experiment other than feeding in, which I don't like doing, but I'll go that way. Alright, so now it'll feed in. Gotta disengage it in the right time, huh? Alright, so 3 thousandths. Engage it. That's a good finish. Not too bad. That's starting to screw up. Alright, so I'll go a lot faster. And the 3 thousandths cut. Should get the exact same finish. 3. Same thing. A little bit better, actually. I know it's still tied together, so it shouldn't make any difference. But just wanted to share that. Alright, down to making the main crankshaft. Started making this part, but I'm looking at it first. And they give you 3 options. You can make it this way, or this way, or a little stub guy, or that way. So, and then I'm looking at this, trying to figure out all the dimensions, and I'm not going to do this, I'll tell you that, tape or something. So I started kind of making this part and shelled it for a minute. I'd love to see how to knurl that face, but so I don't know why they're doing all this big, small, big, small. So I drafted it all up to scale. And you can see, something to point with. I mean, why do all this stuff? So, and there's no bearings. This is aluminum. They call out aluminum, and then they call out a steel shaft. No bearings. So I figured, here's the bearings out of a hard disk. I'll seat this in there. This guy, I probably need to bore this out now. But I just drill it out to sink the bearing in there. I need to turn this down so it's smaller than that diameter. And having a little shelf on it like that will separate this guy from the face nicely. So I'm just going to make it like this. I just need to get the dimensions right on it, because it looks like the actual cam thing or whatever sits against the back of this guy, which is, I did it, absolutely to scale, to their print. So if I make this
fit. You know, the bearing's going to seat down in there. And then I'll have a bearing in the back part here too. And then I'll thread this. I'll see, our prop is on order. So this goes on there. Probably just put a hole all the way through this, thread this, and have that a nut lock the prop down. And then the back, they want to thread this thing so I can easily do that, Loctite it on there, and I'll be set with this guy. Actually, how do you assemble it? This is in place. This has to, yeah, this has to go on there because that's bigger than this thing. So you slide the bearing, pretend that's the back. Slide the bearing on there, slide the whole thing in, and it's done. And then I guess the prop is what keeps this thing from going back in, and the cam keeps it from going that way. So that's the plan so far. Zoom in a little. Looks pretty good so far. Bearings are in there. I figured I'm just going to shorten this. So right now it's got play in it. So that pokes out the right amount, and once I shorten this, I'll be able to have it right on the money, but it looks pretty good right now. Everything fits good. That should be long enough. I did put more of a chamfer on this. I don't know if you want to call it a bevel, but it could be. So I'm not sure. I got to hold this in the vise somehow and just cut that off in the groove. And that, yeah, if it's shorter, it'll look better. And they want a lip on this thing, and I'm not going to do that. I'm just going to take it down to here. So that's all that. Piston's pretty good. It's really a tight fit, let me tell you. It's like right there. Same way with this guy. I mean, you put it on there, you can feel the suction. It doesn't drop out. Shake it a little bit. It's starting to ease out, but what happens if I pull on it fast? It should pull the piston right up. Yep, there it is. Alright, so it's moving along, and I need to cut the chamfer in here to make it look good. I don't know why it pokes up so high. That was their print. I mean, it's like, come on. There, it's bottomed out. That looks weird. That guy on there. So, I got my shaft. Not too much left to do. Finish that. Drill it out. I'll figure out when I get the prop, I'll know what to thread this or turn this to. And what? Oh, how far out is that? It pokes way out, I hope. Oh yeah. There's plenty of room, I think, for the prop. I have to wait for the prop, I guess, before I can cut this back, so I know how far to go. So thread that, finish that, and then do the little cam thing here, which is going to be a pain because I'm going to have a lot of waste. I got to put this thing in the 3-jaw because it's .850. So I'm going to take a 1-inch piece of 1144, cut it off, do all that, and then I got to figure out how to cut that to, what is it, 240 thick. So very close. Let the next show a little bit of parting off this cam thing, whatever you want to call it, for the engine. So yeah, basically face it, turn it down. Print says the diameter OD is supposed to be 850. It won't fit in the engine. Mistake. It's supposed to be 750, which I turned it down to, and I'm just using regular motor oil here for cutting fluid to keep it cool. Kind of a strange grinding sound I'm getting, but everything's working. So it just goes right in pretty quick.
probably at too high an RPM for this, but yeah, I'm gonna slow it down. Yeah. Oh, that's way too slow. Oh, I should have put it in low gear and then just do it. So, pretty easy. It's got a long ways to go to get through this. Whatever half of 750 is, minus that hole. So, and I'm just going to put a set screw on it rather than threading it, and just try it that way, just to see if this engine's going to really work. Alright, well, a little bit of parting. Alright, well, there's the parted off, and it looks like it's a good fit. Grease all over the place. So there's the guy so far. This is done by just doing the facing, but angling the cutter, the insert, and you just stop and come out, and it came out pretty nice looking. So some of the dimensions I think are still wrong. It's a nice tight fit on there, so this should work well. But when I look down in there, somebody's off, so I got to go through some of these dimensions. You can see, I think, where, oh yeah, I can look up there. So somebody's not going to fit in there. I guarantee you that. To be on center, this guy has to get cut back. I wonder what the dimension was, but so I got some fiddling to do to get some things to work right. This will fit in a collet. I already checked it out so that I can face this and clean that up. Then, yeah, just put it in the mill and drill and tap for that, and then I got to make that hole, which was supposed to be, what did it say, 280. Where's the caliper here? And I lost the calipers. There they are, 280. Hopefully that error, because I said the dimension's 850. No, this is it's locked down. That should be 750, 753. So, and what did I say? 280 up to the center of the hole. Please work. Oh, 30, 40, 70, 85. Close enough. Yeah, it looks like it'll be right. Oh, to the center of the hole. So somebody's off here. Because 850 does not go in there. You can see that just makes it. It could have been a little bit bigger. So it looks like, it could be. What size is the hole? 156. That's teeny. 156. Whoops. 165. Oh no, that's big hole. So something's going to have to get changed. I'm glad they didn't drill that out bigger. Wow, this is like... Okay, somebody's really off. Oh, well, he's just going to be doing this number. Okay. I guess I just got to go out as far as I can with it. And just make some pin. I guess probably steel or not. Hopefully, oh, I'll Loctite it in. No, I'll probably thread it. I'll thread it so it'll screw in there and it'll hang on pretty good then. So far, so good. Well, I've already stood it on end between two plastic parallels, the ones that I've made a long time ago that I've shown. Did a 440, threaded it all the way, tapped it all the way through. I put these guys back in because I was thinking that'll hold it, but it doesn't make it. I wind up drilling it right into my vice jaws. So, gauge pins, I swear it's one of the best things I ever bought. It took me less than 2 seconds to put that on center. Zero out the DROs. Now all I have to do is go over, what was it? 280. So x-axis, turn that on, and that's released. Yeah, go over 280. I'm going to see where it's going to hit. Alright, 220, 30, 40, 60, 74, 77, 80. Where am I going to hit? Right on the edge. So yeah, that little screw, let me get it. That little screw will work out. I'll be right on there. What is this anyway? get my metric thing out. This is probably 3. Yeah. Oh, hang on. Yep, goes in there. It's a 3 by 0.5. So, got to set up for drilling that. And then that part will be done. And I don't know what it is about anchor lube, but I'm using it for all the tapping. It lets me go significantly further into a part. Oh, my arm's going to be all over this thing. But you just go right in, man. I'm feeling just slight resistance right now. Back it up for the heck of it. But it'll be right through. Yeah, we gotta bring this down a bit. And there it is, through. Incredible stuff, but you know, I'm glad the test I did a long time ago, since it's water-based, it doesn't rust your tools, because that would really piss me off. Alright, I guess at this point I'm going to call this quits for a video. The number of reasons. Well, this is done, but you really got to follow the print, and I did. In this hole, I didn't go all the way out because there would have been nothing left to the side wall here. It would have been 50 thousandths, and that would have made this bigger. And I think this has to be steel to have the momentum, but this pokes out, so I have to shave this way down if I want to try to do it. This should have been longer. This is actually, I think, longer than the print, but this looks dumb here. And I still have to make a contrary piston, which is like days worth of work. And making this, if you're going to make one of these guys, the Boll Areo 18, you gotta, I think, maybe say you really got to pay attention to the print and double check things. I'm not sure whether I really found anything wrong or not. I've changed numbers, like I said, because I didn't want it that close. What else? This guy should have been thicker. So I am going to continue with this, and if I do get it to run, then I'll bring the camera back someday. But I kind of see how it works too, as far as fuel getting in and the exhaust and stuff. Look, this is pretty cool. I wish, because if I redid this, I'd have to bore that out, which is no big deal. This centers because of the holes, so I don't have to really remake this to fit in there. I can make that bigger than this guy will work. But I think I do have to make that out of steel to get the momentum going. But and the screw idea I think will work, because I can easily countersink the head down into here too, so it clears everything. So there isn't, yeah, the same way with the back piece. Then that thin wall that you saw me make down in there, I just shaved that off because the 4 holes will keep this in place. And I'm realizing to make the fuel go in, this bottom gets pressurized, so this has to be sealed. I'm not sure how well this is going to seal as it is. Probably really good, because I've got perfect finishes. So if you guys want to build one, it's a fun project. It's taken me, what, 4 or 5 weeks, I think, to get this far, off and on working on it, but it's pretty cool. So I will keep working on it, and like I said, if I do get it running or anything, then I'll show that. But for now, I'm just going to call it quits.